for those who attend in the Zoom meeting, please shut down, mute your mic so that we don't have any more noise in the system. So now 7:16, let's start the meeting. And I would like to welcome everybody. In case we haven't met yet, my name is Kai Wong. I am a resident here for over 2 years now. So I met most of you, but not everybody. And I'm part of the engine group. It's called IEE, and a line member group. That means we are older than 60 years old. I mean, most of you here are older than 60. So, but you have to be a member for 35 years or longer. Add up the sum total 100, and you can be a member. So we're happy to be here. We would like to invite Bill to give a talk. But before that, I just want to say, let me turn on the meeting. So just a quick summary. So we have so about some group from Denver and some group from Dallas and Houston are joining us. And locally, we have 2 groups, the line member and also a consultant network group. So just as I said, you need to be old enough to join our group. That's the formula. And normally that's our normal topic, technology or anything interesting, finance, hobby, travel. And we want to hear your engine stories. And actually I'm recording some of the speakers from this area. So that's our election for next year for those members. Those are officers. And tonight's topic is evolution of Panama Canal, and there's a very long paragraph. That's what Bill's going to talk about that later. But Bill is a UT graduate, got his PhD in civil engineering, and his main job is in different fields. He's doing consulting, selling software for the big infrastructure. His specialty is in foundation. And that's why he was invited to Panama to consult and work on that project. And we work on a lot of different projects, and also we wrote a number of papers, and also he taught engineering in Arizona. So I give the stage to you, Bill.
Okay.
Let me
Thank you.
turn this on.
You're going to turn back the PowerPoint on?
And then put another one.
Okay. I just want to acknowledge the fact that I've got a couple of colleagues here in the audience. Gonzalo Vasquez in row 3 went with me to Panama in 2005 when I taught this training course, and he taught the training course along with me. And also in the front row over here is Dr. Steve Wright, who wrote the computer program used to analyze slope stability at the Panama Canal, probably since about 1970 or so. They've used one version or another of his software, and they're still using his software. So there's a lot of people here who know some aspects of the design that I'm not aware of. So, and let me just assure you that the fraction of the Panama Canal expansion that I worked on was maybe 1/100th of 1% of the total project, and they really didn't have any foundation problems whatsoever because the new locks are built on rock. Okay, we have a 1-minute YouTube video we're going to show if YouTube cooperates.
You want to show that first?
Yeah, let's show that first, get it out of the way. This shows a ship going through the Panama Canal, greatly accelerated. That's the, yeah. Just hit the space bar to start. It's not on the screen yet. It's not on the projector screen. It's more trouble than it's worth. That's part of my presentation. That's one of the pictures of the, it's not the YouTube. Yeah. Where's the space bar?
The process of transiting the Panama Canal is very similar for every vessel, from a sailboat to an enormous cruise ship. Each vessel accesses the locks through their gates to reach a height of 26 meters above sea level. A control house operator closes the gates to the locks and then opens the valves that control the water flow. It takes 8 minutes to fill the chamber to elevate the ship, which is kept in the center of its transit by locomotives. This operation is almost exactly the same at the 3 sets of locks in the Panama Canal. It takes between 8 and 10 hours to transit the Panama Canal from ocean to ocean. More than 10 million ships have done it since its opening.
That's it. 1 minute long. Now you've seen a ship go through the Panama Canal. Okay. Now we're trying to get back to slide 1 in the PowerPoint. Okay. Slide screen icon there. Something's happening.
There we go.
That's,
Well done.
that's slide 20.
That's what you have the left click for. Click back.
Okay, let's get started. Okay, this just tells a little bit about me, and I've worked on projects in 17 countries and in 42 states in my career. But the last 20 years or so that I was working as a combination consultant and software developer for software for foundation design and analysis with Insoft here in town. I tried to get my colleague at Insoft to come here tonight, only Gonzalo was able to come. The president of Insoft got on an airplane to go to Taiwan yesterday, so he was not able to be here tonight. Okay, what I'm going to talk about is that briefly how the Panama Canal works, then talk about the Neo-Panamax locks. I'll talk about, give you a general tour of what it looked like in 2005. So I'm going to discuss the third bullet point before the second bullet point. And then I'm going to briefly mention the events that led to the handover of the canal from the USA to Panama in 1999 because a lot of people don't remember what the exact series of events were, and a lot of people are still misinformed about it. And lastly was the Panama palindrome that I mentioned in the comments beforehand. Skip that. Okay, this is the man who told the French how to build the canal successfully, and he was ignored. His name is Gaudin de Lapinay, and he was the chief engineer for the Corps of Bridges and Roads in France. And he had worked on a railroad in Mexico. He had worked in the tropics. He lost a third of his workers and 2/3 of the engineering staff during the construction of that railroad. He knew working in the tropics, if you don't know anything about malaria or yellow fever, is deadly. And he knew that Panama was even worse than Mexico was. So he told the people at this international conference in 1879 that building a canal in the same manner as the Suez Canal was bound to fail. And in 1889, that is exactly the case that happened. The French failed in their effort to build the canal. They, after losing 20,000 workers due to disease and almost bankrupting France. So their basic problem was they ran out of money, and they just tried to build the canal too early in time. Had they waited 20 years like the people from the USA did, then they would have known about yellow fever and malaria being conducted by mosquitoes. They would have had a public health campaign to make the isthmus a safe place to work, and they would have had all the other great things that occurred in the last 20 years of the 1800s to make the world a better place to live and work. So, got to give the man who had the original idea credit for the way the Panama Canal was eventually built. The Panama Canal, you don't go through Panama, you actually go over Panama. So what the canal project consisted of was a dam to dam up a violent river that was impossible to control. And then what you were able to do is form the world's largest man-made lake at the time that it was built. And over this man-made lake, you could sail 23 miles, which was literally halfway across the isthmus, before you had to get into a canal. And you would have locks coming up on the Caribbean side to the edge of the lake. And then there was a 9-mile-long deep excavation that the French had spent all their time working on, and they had actually dug about 1/3 of the total volume of earth and rock that had to be excavated out of that 9-mile stretch. And like I said, they had 20,000 people die in their effort to build the canal. And then a series of locks were built from that point down to the Pacific coast, and that you were able to go across the canal. Now, one of the things that de Lapinay said that was impossible to control with a sea level canal was the fact that on the Caribbean side of Panama, the tides are about 1.5 feet per day. On the Pacific side, the tides are 10 times higher. They're 15 feet tall. So this is the tide chart for today, October 9th, 2025. We're in the same time zone as Panama, so it's now 7:30. So that would be, what, 1930. So we're, on the Pacific side, we're about plus 10 feet, and on the Caribbean side, we're down around 0 feet on the tides. just imagine what would happen if you had the water sloshing back and forth between the Caribbean and the Pacific Ocean. If you didn't have locks on the canal, the environmental impact would have been absolutely massive. Now, Panama is ideally located for a canal across an isthmus like this, because it is literally the world's crossroads. And here are some of the major shipping routes that ships going through the canal. And
Is
if
it
you-
possible to get the slides on Zoom? We're just seeing the ceiling here.
So you got to get it on.
Hello, for those who's on the Zoom, please mute your mic, okay, so as the meeting go on.
They need to
It
share.
says they can't see their
You need
slides.
to share.
I need to share the PowerPoint presentation. Sorry.
Yeah, I just unmuted it to let you know nobody on Zoom sees slides. Thank you.
Thank you. I need to share the screen on this. Are they seeing the screen? Okay, that's not the screen. That's on our slide screen. Share that one, yeah. Yeah, that one. So you should now see a slide screen that says Panama Canal connects the world. And it says, and the next line says nearly 3% of global marine trade transits the Panama Canal. Okay.
Yeah, thank you.
Okay, now we're cooking with gas. Okay. Panama has listed all these nice positive facts about the canal in their annual report, and these figures came out of the 2024 annual report of the Panama Canal. Their principal trade routes by tonnage are U.S. East Coast to Asia, U.S. East Coast to South America's West Coast, South America's West Coast to Europe, South America's intercoastal routes, and then the South America East Coast to Asia. So by tonnage, those are the biggest routes. Now the Suez Canal can compete very effectively for the shipping between Asia and the East Coast of the United States. So when they're adjusting their tariffs and fees for ships going from Asia to the U.S. East Coast, they're always adjusting the fees, trying to get a little bit more of the business away from Suez. But if you're trying to ship something fast at a moderate cost from between Asia and the United States interior or East Coast, the fastest way or the most economical way is to go sea to the west coast of the U.S. and then put your cargo on a train, because trains go a lot faster than ships do, and they're cheaper than ships are. So that's the other competitor that they have, other than the Suez Canal, are the transcontinental train networks in the USA. Now the clicker's not working. Okay. Can I just hit the page down button? Okay. I'm going to talk about the new Panamax locks next. this is where I want to be. Okay, the so-called third set of locks have been designed on at least 4 prior occasions by the Corps of Engineers. Once was during World War II. They wanted to have the ability to get some of the larger aircraft carriers through the Panama Canal. The original straight deck aircraft carriers could get through the Panama Canal, but if you had any of the angle decked aircraft carriers, they were a little bit too wide to get through the Panama Canal, so they wanted to widen the canal at the tail end of World War II to get those aircraft carriers through the canal. But then they won the war, so that project got canceled. And then the same thing occurred again during the Korean War. They wanted to widen the canals so they could get the aircraft carriers through. Then the Korean War was over. And then later during the Vietnam years, they wanted to widen the Panama Canal, and again, the war was over. So they didn't need to widen the canal. And then later in the 70s and 80s, when the U.S. was importing a lot of crude oil, then they wanted to widen the Panama Canal so you could get larger oil tankers through the Panama Canal. And then what happened? The oil industry invented fracking, and U.S. domestic production went up. They didn't need for the super tankers to go through the Panama Canal, so they got canceled the 4th time. But what prompted Panama, when they took over the canal in 1999 to build the larger set of locks, was the development of container shipping. And even today, the container ships that are the largest container ships in use cannot go through the Panama Canal. The MV Dolly that knocked down the Francis Scott Key Bridge in Baltimore could not go through the Panama Canal. It is too big to go through the Panama Canal, even with the new locks. So there are about 4 or 5 sizes of container ships that have been standardized that are larger than the Neo-Panamax size, which is the largest size that can go through the Panama Canal that exists today. So the Neo-Panamax locks had been designed by the Panama Canal Authority, and they probably started people working on a design for a new set of locks as soon as they saw the development of the container ships occurring. And the container ships really are the most dominant form of shipping that goes through the Panama Canal. The U.S. military always has top priority of getting through the canal. So if a Navy ship comes up, they get to go through the canal without waiting in line. The other thing that the Panamanians had implemented that was different from the way the Corps of Engineers was running, or the old Panama Canal Company was running the canal, is that it used to be first come, first serve. Then they implemented a way where companies could bid on transit times. So they could schedule their ships to arrive when they were supposed to arrive and go directly into the canal without a delay, and then cross the canal as fast as possible and then continue on. And the reason they implemented this is that they published the times that a ship could cross the canal and allowed people to bid on those times. So it was an open auction that the people could bid on. So if you were a shipper and you had a shipload full of high-end Lexus automobiles that you wanted to sell as fast as possible, you would pay top dollar, go across the isthmus, and as fast as possible, so you can get rid of your high-end automobiles faster. But if you were shipping scrap iron back to, say, Korea to be recycled in steel, as recycled steel, you could afford to sit at anchor for a couple of days before your slot came up. So then those people would bid a smaller amount and they may have a bit of a delay. Now, the Neo-Panamax locks were designed in a manner where they can save water. And the way they do that is that they have recirculating basins off to the side. So the thing you've got to understand about all the locks on the Panama Canal is that the water only flows downhill. There are no pumps anywhere. All the water flows by gravity. So what can happen is that if there is a drought in Panama, as there was recently, the amount of shipping that goes through the canal is restricted because presumably the Lake Gatun could run out of water. And since it's also the principal drinking water supply for the majority of the 4.8 million people who live in Panama, they don't want to die of thirst, so they don't want the canal to be drained in favor of the ships. They want the ships to pay top dollar and have fewer ships go through the canal so they can have drinking water all year. Now, in the Neo-Panamax locks, they have 3 lock chambers going up and down to the 85 feet above sea level that you need to get to the standard pool depth of Gatun Lake. On the Caribbean side, that means that you're typically going up about whatever 85 feet divided by 3 is. So it's a little less than, 28 feet or so for each lift. But on the Pacific side, since the tides can fluctuate by 15 feet, and you have to be able to accommodate the draft of the ships. The draft, I believe, is 15 meters, which is approximately 50 feet. So you've got to accommodate a ship that is sticking as much as 50 feet down in the water and be able to be lifted up to 85 feet above sea level from potentially being at low tide. So the amount of lift on the locks on the Pacific side have a little bit more range than the locks do on the Caribbean side. Now, the way the recirculation basins work is that each lock chamber has 3 recirculating basins that have basically the same cross-sectional area of the lock chamber. So what they're able to do is that they're able to fill a recirculating basin up to the depth to where the water level is equalized between the saving basin and the lock, and then they'll close the valves off to that recirculating basin, and then they'll start draining water down to the next one. And then when that one's full, they'll switch the valves and fill up the third. They're not able to save the bottom 40% of the water that would be going out of the canal from that lockage for that ship. So if you have a lock, this is the general rule. If you have a lock with savings basins, water saving basins of the same cross-sectional area, think of that as having a number n, okay? You can take n plus 2, divide that by n, and that's the percent of water that you can save when a ship goes through a lock. So if you could design a lock chamber that would have 8 basins, you could save 80% of the water. If you could, only had one water-saving basin, you could only save 1/3 of the water. So that's the way the math works on the water-saving basins. And they work great because they have the lock chambers fairly close to the volume of the ships that go through the locks. And when that happens, that means that you don't have to replace the water that is displaced by the ship. You only have to replace the water that is around the hull in the lock chamber when the ship goes through that lock chamber. So you go through all the calculations, even though you're passing a ship that may be 250 feet longer, 15 feet greater draft, 54 feet wider in beam, and 2.7 times with as much cargo on it as the old style locks, you'll end up using 25% less water to get that ship across the isthmus. Once you start factoring in the efficiency of the how much it costs to move a container per 20-foot container, you will save 78% of the water that would have taken you to move that same container on a Panamax vessel across the isthmus if you had that container on a Neo-Panamax container ship. So the new set of locks, any way you look at it, are a tremendous success and are well worth the $5 billion plus that they had to spend to build these new sets of locks. If there's a future drought that you'll probably have, they will restrict the traffic of the smaller size ships going through the canal because they're much more inefficient for the water that's lost going through the canal than the new ships are. The larger ships are more efficient. So the reason that I mentioned this is that in around 2020, 2022, from about 2019 to 2022, there was a drought period in Panama caused by the El Nino being particularly strong. The amount of rainfall that they had falling on Panama dropped precipitously during that time. Global warming possibly had another effect on it as well. But the amount of water was not the 155 inches of rain per year that they were getting around 1914 when the canal was open. It was down to about 100 inches of rain per year. And made a difference. That's why they were running out of water on the canal. Plus, the amount of shipping going across the isthmus was going up dramatically. Okay, here's just some calculations going through, calculating the amount of water lost. And you can do adjustments for the displacement of the ships and all that sort of stuff. Okay, let's talk about the route of the canal. So here in the inset map, you have the location of Panama between North and South America. And then up here, you've got the 52-mile isthmus blown up to full size, or much larger. And you see that Panama City is located on the Pacific coast, the so-called South Sea, even though you're in the northern equator. By the way, Balboa, the man who, the Spanish explorer who crossed the isthmus in the early 1500s, was the guy who named the Pacific Ocean the South Sea. And the reason he named it the South Sea is that when he crossed Panama, it was on to the south of Panama. That was how it got the name the South Sea, even though it was in the northern hemisphere. Just a little trivia for you. But anyway, there's 4.8 million people who live in the nation of Panama. About 408,000 of them live in Panama City, which is located near the Pacific entrance of the canal. And then the original canal zone controlled all of the property around the canal up to elevation 100 feet above sea level. So that is all of that land is owned by the current Panama Canal Authority. So on that land, you have the Panamanian Railroad, which goes across the isthmus, which is carries a lot of cargo itself. And also, they have future plans to put in some oil and gas terminals on the two coasts and have pipelines crossing the isthmus so that a oil company could offload part of their crude oil cargo or natural gas and get it across the isthmus and put it on another tanker or natural gas ship on the other side. The 9 miles of deep excavation is where the work went in to build. The majority of the work went when they were building the Panama Canal. That was originally called the Culebra Cut, and the U.S. Corps of Engineers Army officer who was in charge of the majority of the work on the Culebra Cut was a guy named Lieutenant Colonel David Guyard. And in 2000, the Panama Canal Authority renamed the Culebra Cut the Guyard Cut in his honor, because he's the guy who really did the hard work for the U.S. to dig the Panama Canal. Okay, the locks were designed by the canal authorities between 2006 and 2010. That's when they were really getting things finalized. They had a national referendum in 2007, and the population in Panama voted in favor of potentially hurting the country economically by building the new sets of locks. But you got to remember, it's only 4 million people or so spending $5 billion. That's a big bill, and they voted as a country to do it. Then they started construction in 2007. They completed it in May of 2016. Around 2010, they had an engineering conference down there where it was the opportunity of a century to go down there and visit the construction. And they had some big engineering conferences down there. And you were able to take tours through the culverts of the new locks and things like that. They will never be dry ever again, so you will never be able to do that. If you didn't go down there then, you missed your opportunity. So the first commercial traffic crossed in 2016, and like I said, the new locks are a huge success. Oh, with regards to the sizes of container ships that can go through, this is a comparison between the Panamax and the Neo-Panamax size container ships. And like I said, there's like 4 or 5 standard sizes of container ships bigger than the Neo-Panamax size. I think the biggest container ship today can carry something like 26,000 TEU containers. So the largest of the Neo-Panamax that can go through is around 12,500, 13,000 TEUs, which is a substantial increase over the Panamax size ships, which were 3,000 to 3,400 TEUs. And this is just a comparison between the dimensions of the old locks and the new locks. Now, when the old locks were built, people wondered, why in the world did you build a lock that was 1,000 feet long and 110 feet wide? that was the size of the barge tows going up and down the Mississippi River at around that time period, and that was the standard size lock that the Corps of Engineers was used to building on the waterways in the USA. So they didn't want to do a bunch of really radical new engineering. They more or less copied what they were doing. And there are locks in the USA that actually have higher lock lifts for that size lock chamber than we have on the Panama Canal. The drawing on the bottom of this slide shows just how the water-saving basins work. And I believe on the next slide, I have an animation that hopefully will work when I click. So you see the top part is draining into the first basin, the valves switch over, and now we're draining into the second basin, and now we're draining into the third basin. And then the bottom 40%, well, it didn't continue to go down, but it should have. That's a mistake on my end, PowerPoint slide. I'll fix this if I ever show it again. But that, anyway, that's how the Neo-Panamax water-saving locks work. But when a ship's being lifted, the whole process goes backwards. So here is the picture of the locks on the Atlantic side. And the reason I know it's the Atlantic side is that that is the new Atlantic Bridge under construction by those locks. So this picture was taken around 2020, because I think the Atlantic Bridge opened up around 2020. And this is also another picture of the same locks, but from the air. And here you see the dimensions of the locks. Those lock gates that cross the, are pushed out from the side. And like I said, the lock gates are a little bit taller on the Pacific side. Would you like to guess how tall those lock gates are? They are the height of an 11-story building. And they float. And they're pushed out. And then once the water starts to drop, the water pressure seals the gates. And you'll note that they've got double gates between the most upstream locks. And the reason they've got those double gates, if a ship breaks the gates, they don't want to drain the lake. So they've got redundant gates on the upper chamber on both sides. Okay, here is a tour of the Panama Canal that Gonzalo and I went on in December of 2005. We were flown around by a friend of ours named Chris Dillon, who's a contractor who lives down in Panama. His grandfather moved to Panama from the U.S. to work on the canal when it was being built, and his family just stayed there. And he is a graduate of Balboa High School, which was where we were teaching our training course. And I should also mention that when I was in graduate school, my roommate in grad school was the son of two school teachers who taught at Balboa High School, and he grew up in the Canal Zone. So a lot of the gossip I know about the Canal Zone I learned from my roommate at the time, who was, in his parlance, he was a zonie because he grew up in the Canal Zone. So some people call themselves Zonians. So he referred to himself as a zone. Okay, now let me just mention one thing. If you ever go to Panama, it is absolutely essential that you rent a car with GPS and you have a driver who can speak fluent Spanish, so when you do get lost because of all the one-way roads in Panama City, you can ask for directions. Because Lots of times you want to go 100 yards down this street and you can't do it. You know, there is some obstruction in the way, so it is the toughest place to navigate I have ever been to in my life. And it's worse than Athens or Rome in getting around. And those cities were laid out along the goat trails from, you know, before Christ. So it's really complicated to get around that city. That was the picture from my hotel room, by the way. Okay, I'm just going to show you the route that we flew when we visited the canal. So we're following the blue line. That was our flight path. So we take off from the old Albrook Air Force Base, which is just to the southwest of Panama City. And then we flew by the Bridge of the Americas, which existed then. Right now, there is a new bridge that is higher than the Bridge of the Americas that's under construction. It's known as the Fourth Bridge, because it will be the fourth bridge over the Panama Canal. And so far, it doesn't have a name. It's just called the Fourth Bridge, but it's 21% complete right now. And it will be a substantial bridge. It'll have both rail and bus lanes and probably 6 or 8 lanes of traffic. It's going to be a much more a bigger bridge than the Bridge of the Americas is right now, which I think is 4 lanes. By the way, the feature that restricts the sizes of ships that go through the Panama Canal today is the Bridge of the Americas. It's only 190 feet above the water at high tide, and that's what keeps a lot of ships from going through the Panama Canal. A lot of cruise ships cannot go through the Panama Canal because they're too tall. They're narrow enough to get into the locks, but they would hit the bridge. So they're going to, the new bridge is going to be 250 feet of clearance, so it'll be 60 feet more clearance than the Bridge of the Americas currently has. So what we're going to do is we're going to make a U-turn, then fly on the right side of the canal, the left side of the canal, and we'll go past all the locks and we'll see the principal parts of the Calabar Cut. And then we'll go along the Calabar Cut till we get up to the city of Gamboa, where the lock maintenance facility is located, and then we'll cross over Gatun Lake, and the ships go 23 miles across Gatun Lake until they get to the Gatun Locks, and there they go down to the Caribbean. And I'll show you a picture of the Gatun Dam, which was the largest dam in the world when it was built by volume. It's half a mile across on the base of the dam. And then we make a U-turn and come back down the other side. But I'm only going to show you slides from going up because it looks the same coming back the other way. So I had my camera, so I got to sit in the front seat. Gonzalo had to sit in the back seat of the airplane. And Chris, the pilot's in the left seat. It's the only time I've gotten to ride shotgun in an airplane. There is the Bridge of the Americas. And down below is one of the, that's the Pacific side old Navy base. And those piers that stick out into the canal there were made for battleships to tether up to defend the canal. Okay, the old port area has been converted into a container port, and our company has worked on the design of basically half of what's in that photograph right there. And then there was an extension that was built off to the left, and we also got to do a lot of the structural design on that as well. So you can see the old Albrook Air Force Base, that's where we took off, and the Balboa container terminal. People are always concerned about the the Chinese Liberation Army taking over the Panama Canal. It's the Chinese shipping companies that buy up all the container port facilities around the world, but they also own all the shipping that goes to the container port facilities. So you see the big players in the shipping business that operate ports. You've got Hutchison Holdings is one, they're out of Hong Kong. Most of their executives are Australians. Then you have MSC, that is Malaysia Shipping Company. And then there's Costco, COSCO, and that's Chinese overseas cargo operators, or I don't know what this, or company, I guess. And then you've got Evergreen, which is outside from Taiwan. So those are the principal operators of ports around the area, around the world. And I tell you, those guys travel more than anybody I've ever met in my life. The chief engineer of Hutchison Whampoa was traveling around the world 4 times every year, going from project to project to project. And you have to do that every 3 months. Okay, when they did some of these earlier efforts to build the canals, now this photograph is taken in 2005. You can see some of the excavations that were left over from the work that was done in World War II when they were going to build a 3rd set of locks. And that is where the Pacific side locks were located. So those excavations from World War II were eventually adopted for the use of the new locks. So while we have 2 sets of locks on the Pacific side with Miraflores with 2 lock chambers and Pedro Miguel with 1, the channel for the Neo-Panamax locks on the Pacific side goes all the way around those locks, and it skips going through Miraflores Lake, which is 54 feet above sea level. That is the Panama Canal Museum, that building right, does this have a laser pointer on it? Sorry. Where is it? You probably can't see the red dot, it's not very prominent, but right there, that little building by that lock gate, across from the control house, that is the Panama Canal Museum. And we get various places around town that got some of the old construction equipment that was used to build the Panama Canal. Yep. They look like toys today. Okay. I did something, and maybe I turned it off. I'm trying to get the clicker one. It's not working. Okay. No. Something, okay. Now, there we go. That's what the problem. Okay, this is just a slightly different view of the Miraflores locks. These are the Pedro Miguel locks. These are just upstream, maybe 1 or 2 miles upstream. And then Miraflores Lake is, the start of the Calabar Cut is just over the right side of the screen. And this photograph I got from the website of the Canal Authority. And this shows the Pedro Miguel locks, the start of the Calabar Cut, and that is the Bridge of the Americas. There, that is the second bridge that was, that's Centennial Bridge. And that bridge was built in 2000, I believe, for the, no, it was It was there in 2005 when we were there, so I forget exactly. Maybe it was like 1998 or 1999 that it was built, but it was there in 2005 when we were there. No, it's called the Centennial Bridge, 2004 or 2003 it opened up. Because Panama was founded on the 3rd of November, 1903. That's when Teddy Roosevelt sent the Navy down and recognized Panama as an independent country after their annual revolution that had occurred every year since 1850. Finally, Colombia was wanting too much money to get a license to build the Panama Canal, so they didn't make a deal with with Colombia. They stole Panama from Colombia, and part of the deal was that Panama made the deal with the USA and bargain price. And they wanted to be independent of Colombia all along anyway. Okay, going into the Calabar Cut, this is the hardest part of the entire project, right here. This was the excavation through the so-called Gold Hill. This is hard rock that was difficult to cut through, and it was the highest piece of ground that they had to excavate to build the Panama Canal. And it was also a point of fraud on the part of the French, because when the French were selling bonds to finance their construction effort back in 1880, they were telling everybody that there was enough gold in this hill to pay for the entire project. And guess what? Not 1 ounce of gold has ever been found. And this is more of the Calabar Cut. And this is probably down when they're in the Cucaracha clay shale, which is famous the world over for having the absolute worst shearing properties of any soil known to man. And you look at it the wrong way, it's gonna slide. I mean, it is literal jello, ready to slide, and they still have to dredge to keep the canal open to this day. And it's been a non-stop operation ever since the canal opened up. The canal will have landslides into the canal. This is the lock maintenance facility near the city of Gamboa, and that crane there is a crane that was taken away from the Krupp Iron Works in Germany as war reparations after World War II. And it's a big crane. And it is used to lift the locks up when they need to replace a lock and take it to the maintenance facility so they can scrape all the crud that's been growing on the gate off, and also paint it and repair the gate for all the corrosion that's been taking place and things like that. So that is a picture of that same crane in operation, and it's in the process of lifting up one of these gates, which are 75 feet tall. And the gates on the old locks are so-called miter gates. So they meet in a V, and the water pressure closes the gate even tighter against the sidewalls of the canal. And most locks operated by the Corps of Engineers have miter gates in. Also, you can see that there's a railroad track on both sides of the old locks, and that's where the electric train cog trains are that pull the ships through the canal. Now, in the new locks, they use tugboats to pull the ships through, but there's so little clearance around the ships in the new canal, the new locks, relative to the cross-section of the ship actually has to turn the screws on the ship to help push the ship through the lock chamber. That's one thing that's different. Now, is a picture of Gatun Lake, and you have to zigzag your way through the islands that have formed that were the old hilltops that didn't get flooded. And if you're alert, you can see some of the navigation aids that the pilots used to navigate through the canal. Originally, the navigation aids were like telephone poles painted international orange or white so that they could be seen. And if it was foggy one day, ships didn't go through the canal because they couldn't navigate. But now they've got like microwave relays on them and all that sort of stuff, so they can know exactly where they are at all times. So they'll get up to a certain location, and then as soon as they get sight of a navigation aid on the next part of a turn, then they'll do a turn. And the pilots are skilled and know how to do it. To steer their way through the canal at any point. 24 hours a day or night, any type of weather. Now, for the Panamax-sized vessels, the small ships, the canal is wide enough to where you can have two-way traffic 24 hours a day. But along the Culebra Cut, that 9-mile stretch between the Pacific locks and Lake Gatun, the Neo-Panamax ships have to go alternating one way, so that the canal is not wide enough for those big ships to pass one another, going in opposite directions. So they'll have a couple go single file, one after another, and get some going through, and then they'll let them clear the Culebra Cut, and then another group will be headed back south. So that's the way that it operates. So there's two ships passing on Gatun Lake. Now here is the Gatun Dam and the Gatun Locks on the Caribbean side. On the left side you see the Gatun Dam, and it's an earth and rock embankment dam, and you see that the dam is quite wide. I think the slopes are something like what's 5 to 1 or 6 to 1. They're a lot flatter than what you would see on a typical earth dam, made out of better quality materials in the U.S. But the other thing is that they wanted to get rid of as much of the excavated material as possible, so they made the dam extra wide, because it allowed them to put that extra earth and rock into the dam. There was also a hydroelectric plant built at the dam. So from the beginning, the lock gates were operated by electric motors to open and close those gates. But they're so precisely balanced that the amount of horsepower required to open and close the old gates is only a 40 horsepower electric motor. And here are the Caribbean locks, and that's the Neo-Panamax locks. And I've actually shown you that photograph before. Okay, the dam was built not only for the hydroelectric project, but also to dam up the Chagres River, which was the roaring, uncontrollable river that people couldn't cross when it was in flood stage. So at where the Chagres River meets the Caribbean, there's an old Spanish fort there. And this is Castillo San Lorenzo. De San Lorenzo. This is the old Spanish fort that existed from the times of Balboa. And this is the city on the Caribbean side. This is Colón and Cristobal. And Colón is where a lot of the Europeans showed up first, because it's on the Caribbean side. And the old Panamanian Railway, when it was built, went from Colón over the isthmus to Panama City. And in the years until the canal opened up in 1914, for those 14 or 15 years that the Panama Railway did not have competition from the Panama Canal, it was the most profitable company listed on the New York Stock Exchange. And it typically paid a dividend that was something like 35 to 40% of the stock price. But it didn't make any difference what the stock price was. You couldn't buy shares in the Panamanian Railway because no one was selling their shares.
That's right.
So, you know, who else is paying a dividend like that? But it was the most it was like the Berkshire Hathaway of its day. But 14 years after it went into operation, then the canal opened up and their business went away. The Navy base on the Caribbean side was over there off to the north, or actually that's off to the west side of the Colon Peninsula in Limon Bay. And that was where we had our very first project in Panama for the canal side. And we were assessing the structural condition of the battleship wharves that were built around 1910 to see if they were strong enough to put a container crane on. And parts of them were and parts of them were not. Okay, now I want to talk about the events that led to the turnover of the canal from the USA to Panama. In 1964, on December the 9th, there was a small demonstration that started when 19 college students left the University of Panama, and they decided that it would be nice if they could raise a Panamanian flag next to the U.S. flag in the canal zone. So they went into the canal zone and they saw a U.S. flag flying in front of Balboa High School, which was one of the two American high schools in the canal zone. And they took a flag down and put the Panamanian flag up. And during the recess, some high school boys came out and they says, "Hey, you can't do that. You know, that flag is our school flag," or whatever. And they hauled the Panamanian flag down, and then people started tussling over the flag, and the flag got ripped in half. And then that really got people mad, and the word got back to the city of Panama that the high school students had torn the flag in half. Nobody knows what happens for sure, but then there was a riot got started, and it got bigger and bigger and bigger, and eventually there were 5,000 people in this riot. And you got to sympathize with the Canal Zone police at the time, because they were on high alert. The Bay of Pigs was 1962. 48 days before was when JFK got assassinated. People didn't know if there was a revolution underway or an invasion of the U.S. underway or anything like that. And so they were on edge, plus their kids were enrolled at the school. So they wanted to make sure these protesters stayed away from their children. And you know, some people got overexcited. Who knows who started shooting a gun first, but at the end of it, the riot, there were 21 dead Panamanians and 4 dead soldiers. And it was an unfortunate situation. And when, you know, Lyndon Johnson had only been in office as president for 48 days, he did not want to be dealing with something going on in Panama at that time. He had other problems to solve. So, if you go and you read the official U.S. history, they'll say that the reaction of the U.S. government at that time was quite measured. And anyway, this is a description of the events of January 9th, 1964. I was saying December before, I meant January. And again, JFK got shot on the 22nd of November. 48 days later, this riot occurs in Panama. People were killed. And eventually, what ended up happening is that the nation of Panama severed diplomatic relations with the U.S. Now, up until that time, the only treaty that existed between the U.S. and Panama regards to the canal was the original 1904 treaty that was negotiated at the direction of the United States so they could, quote, legally go in and build the Panama Canal. But the Panamanians wanted to have a bigger role in running the Panama Canal because it's in their country. And, you know, for example, the pilots who were steering the ships through the Panama Canal, they were getting paid great salaries, but they were only hiring U.S. citizens for those jobs. So they wanted to get some of, you know, those good paying canal zone jobs. So what ends up happening is that LBJ was the first president since the canal was in existence who had any inclination to even discuss the situation with the Panamanians. Now, what I'm telling you is the Panamanian point of view, because when we were teaching at the old Balboa High School, there is a memorial to the 21 Panamanian students who were killed during these riots in front of the high school. And I came in and I said, what's this person who this facility is named after? What did he do? Who was he? He was one of the 21 students who had gotten killed. And I actually read up about this poor guy, and he hadn't even gotten to the canal zone. He was walking to the canal zone to see what was going on at the riot, and he got hit by a bullet. Nobody knows who fired the bullet, but it crossed out of the canal zone and hit this guy walking along the street inside, outside the canal zone, and he was killed on his way to the riot. And he's the guy who got the training center named after. But if you read the official history, the U.S. was trying to be a good neighbor. They didn't want to get the rest of Central America mad at them, so they were being very cautious and sober. But like I said, they were the first U.S. administration that was even open to negotiation with the country of Panama about taking over the Panama Canal. Informally, the word is that LBJ says, why are we still running the Panama Canal 50 years after we built it? Can't we foist it off on these other people and let them run it for us? And the answer was, well, yeah, we probably could. And he wanted to give it to Panama immediately. And then fortunately, somebody said, wait a minute, we don't have anybody in our country who's qualified to run the Panama Canal. We need to be trained on how to run the canal. We've never done that before. So what they started was, informally, they started hiring more and more Panamanians to work in the canal zone and to work on the Panama Canal. They have about 8,000 employees at the Panama Canal doing various things. Okay, so over the years, LBJ started it, and it's hard to get the State Department to get started on things like this because they have their own bureaucratic inertia and they have their own set of priorities. And I remember hearing stories about people in the White House always being frustrated with the State Department because they can't get the State Department to do what they want them to do. I can tell you lots of stories. Okay, but anyway, this is the way that the situation was perceived by the Panamanians. So then, later Jimmy Carter is president, and he wants to have some foreign policy successes. And this was really considered to be low-hanging fruit for the Carter administration. Furthermore, it had bipartisan support in Congress. So Panama, they had signed 2 treaties. Basically, one says one treaty says we're going to turn over the canal on December 31st, 1999. From that point onward, it will be controlled by the Republic of Panama. Between now and then, we are going to start training Panamanian engineers, tailor them to be brought up into management of the canal. And by the time they got to the end of 1999, the last U.S. citizen working for the Panama Canal was the director. In 1999, he retires. His successor is the Panamanian. And that's what happened on December 31st, 1999. The second treaty was basically a treaty that said the canal access is open to all countries. No country will be prevented from using the Panama Canal. So if the old Soviet Union wanted one of their nuclear submarines to go through the Panama Canal, they could have done so. But there's no way in the world they would have done so, because guess what? The U.S. Navy records the sonar signature of every ship that goes through the Panama Canal, and they're still doing it. That's not news. That's an open bit of information. So anyway, that was the outcome of the treaty that got signed when Jimmy Carter was president. And I think I had a list of the people who were supporting this is the people who supported turning the canal over to Panama. I think they're pretty much a solid cross-section of U.S. political power at the time. You had the Joint Chiefs of Staff. They wanted to turn it over to the Panamanians. Colonel Zumwalt and General Maxwell Taylor were also very public in their support. Amongst the Democrats, you had Senator Robert Byrd. He was the hard one to convince. Ernest Collins of South Carolina, Hubert Humphrey. The AFL-CIO president, George Meany, thought it was a good idea to give the Panama Canal to the Panamanians. Zbigniew Brzezinski told everybody if the Panamanians ever shut down the canal for any reason, we would invade Panama, make sure the Panama Canal stayed open. And that was the excuse they used to arrest Manuel Noriega in 1989. And then you've got all these diplomats listed, Averill Harriman, Dean Rush, George Ball, Henry Cabot Lodge, John Sherman Cooper, and Lady Bird Johnson supported the turning over the Panama Canal to Panama. And now on the Republicans, Senator Howard Baker, President Gerald Ford, Henry Kissinger, William F. Buckley, and John Wayne. And then the foreign leaders, Prime Minister and Presidents of Barbados, Bolivia, Dominican Republic, Guatemala, Nicaragua, Peru, Chile, Costa Rica, and Venezuela. Probably the last time the leaders of those countries ever agreed on anything ever did, other than the fact that they like to play soccer. So anyway, that was what happened down at the Panama Canal. I haven't been following my time. I think I'm way over my time. So let me cut this off right here and open it up to questions. And I'm sure we we're bound to have somebody who's here either from Panama or grew up in Panama or somebody like that, because you run into them all the time. Did you know that Stephen Stills, or Crosby Stills, and went to high school in Balboa High School in Panama? There was other famous people who lived in Panama. Any questions? Yes?
So you spoke about those new locks. When they put the new locks in, how did they replace the old locks? Going parallel with the old locks?
They're parallel to them.
So are they still parallel today, or did they shut down the old ones?
No, they're still using the old
Okay,
ones.
okay.
Yeah. But if they ever get into the water crunch that they had before, they will give preference to the large ships going through because they're so much more efficient using water than the old locks were. And they've actually added some recirculation ponds, or the ability to do cross draining in the old locks. So the old locks don't waste as much water as they originally did. Yes?
You mentioned that they were building a new bridge, the fourth bridge. I
The
think.
fourth bridge, it'll be parallel to the,
But there was a bridge that was preventing the taller ships from getting, are they gonna wreck that bridge?
they're gonna take that one down.
Okay.
That's the only thing that's stopping some tall cruise ships from going through is the so-called air draft of that bridge. It's 190 feet at high tide. And the new bridge will be 250 feet above the water at high tide.
Yeah, I guess that one had to come down because otherwise it would defeat the purpose of the new bridge in the first place.
Yeah, and the other thing is that if you look at the Ford class or the Nimitz class aircraft carriers, the reason that they can't go through the Panama Canal today is because they're too tall. They are actually small enough to fit in those new locks. But they're too tall that they'd hit the bridge. They can't go through today, yeah. Yes, Bob?
Just another question, just as an internet junkie, I keep seeing stories about proposals to do alternatives to the canal. You know, rail routes north of it, through, any comments on those?
Well, they've got, first of all, they got the Panamanian Railroad working right now. And I actually took a web camera picture of the Miraflores, or the Pedro Miguel locks today around lunchtime. And the reason I captured the picture is that there was a train going through carrying container. There was no ships going through the lock at the time, but there was containers still crossing the isthmus. That's actually the fastest way to get cargo across the canal. It takes a ship between 9 and 11 hours to cross the isthmus right now, but a container ship can come in to a container port on either coast, offload containers, put them on the train, get them across the isthmus within 3 hours, load it onto another ship, and that ship will depart. So that's the fastest way to get containers across. So you look at all these shipping companies, they've got their shipping, the container ships running on a schedule like an airline. And they'll show up at a specific place at a specific time, and they're offloading containers. And they will have some ships that only steam up and down the east coast of the Americas, other ships that go up and down the west coast of the Americas. So when they get to Panama, they just take a fraction of the containers off that are going to the opposite coast, and then they let them cross the canal on the train.
Okay.
Cross the
Thank you.
isthmus on the train.
Thank you. Thank you.
Sorry, I was a bit long-winded.